Okay, 13.2 general angles and radian measures. Now, in this section, we are going to be sketching angles. And the way we do that is you have what is called an initial side. Okay, that initial side is always on 0 degrees, the positive x-axis. Okay. So standard position then, the position of an angle whose vertex is at the origin and whose initial side, so that side we highlighted there, is the positive x-axis. And then we also have that terminal side which tells us the angle. Okay. Now, that next side you have is called that terminal side. So the measure of an angle is determined by the amount and direction of rotation from the initial side to the terminal side. So if you look here on the one that's drawn, okay, you notice that it has an arrow in which direction it goes. Okay, that is counterclockwise, and positive is when it rotates counterclockwise. If it was to rotate clockwise, so if it was to go the opposite direction, that is a negative angle. Okay. All right. So just looking here, a bunch of different ones. We're starting right here, and then we're going to follow around. Okay. That first one, okay, right here, that is 30 degrees. Okay. If you notice, we all know what a 90 degree is. Okay. 90 degrees, and that's about a third of the way. Third of 90 is 30. Okay. Halfway, right here, that's 45 degrees. Okay, and then 2/3 of the way, 65. Okay, and then again, 90, we should know that one. Okay, and again, 0 degrees on that initial side. Now, if we just follow that pattern, okay, so we go another third, that's at 120. Okay, another 15, 135, 150, okay, and then 180 is a straight line. Okay, keep going, 210, 225, 240, and then 270. Okay, another 300, 315, 330. Okay, and then we get back to our positive x-axis. X-axis, that's 360 degrees. Full rotation is 360 degrees. Now, if you notice, okay, we just followed this arrow, the direction arrow. Since we went counterclockwise, it's positive. We don't have to stop right at a full rotation. We could keep going. Okay, if you notice, go again. Okay, another 30 degrees past 360, that's 390. Another 15, that's at 405. Okay, you can keep going and keep going. Okay, if you ever watched the Olympics, okay, like Shaun White on the snowboard, you know, he does a 1080. Okay, 1080, one rotation is 360, another one 720, another one 1080. Okay, that's what they mean by a 1080 when you watching it in the Olympics. It's just the number of rotations that the snowboarder or skier or whatever is going on has done. Okay, so to draw that angle, every single time what you need to do is draw the initial side, and again, remember it's the positive x-axis, so that will be drawn every single time. Now, in this first example, we're doing negative 120. So we want to draw a negative angle, which again, negative tells us to go counterclockwise. You need to have this arrow. Okay. Okay. So far I've got 90 degrees, so I need to go another 30 degrees. So if you remember, each quadrant is going to be 90 degrees, so we got to go about another third of the way. And I'd say right about there. Now, I understand these aren't going to be exact, but you need to get close. Okay. So if I was to see this, okay, you know, negative 120, I'm only supposed to go another 30 degrees past that negative 90. So I need to see something on this side of that 45. Like if we were to cut this quadrant in half, I need to see that arrow on that bottom side of it. Okay. So it doesn't have to be exact, but it need to be in the general facility. All right, the next one. Okay. Again, draw that initial side right away every time. It's positive, so we're going to go counterclockwise. 400, which is more than 360, meaning we need to do a full rotation. Okay, so we've gone 360 degrees so far. We need to go another 40. Now, let's cut this in half. And since we're going 40, we want to get close to that halfway mark, but not quite. Okay, so I'm going to say right about there. And that's a 400-degree angle. Okay, now, let's say we're going to do one more and say 40 degrees. 40 degrees, positive, we got that initial side here. And then 40 degrees, just under halfway. Okay, same thing, again, draw your direction. There's our angle. And if you notice, that terminal side, the terminal side here, right, this one, is the same exact as that one. Okay, they're two different degrees, but they still have the same terminal side. When that happens, these are called coterminal angles. Okay, so when angles in standard position, okay, that's what we're doing here. We're drawing an angle in standard position. When the in standard position have the same terminal side, okay, just like 440, they ended up on the same terminal side. It looks exactly the same. Okay, they're called coterminal angles. So if you think about it, the only difference between 400 and 40, in 400 we did a full rotation and then just another 40 degrees, just like we did with C, just 40 degrees from the initial side. So all it comes down to when you're finding a coterminal angle is doing a whole nother rotation counterclockwise or clockwise, depending on if you want it positive or negative. Okay, so it says for this one, find one positive and one negative angle that are coterminal with 100 degrees. Okay, so let's do A. Our initial one, let's say positive. We're going to do a negative one as well. So again, it's just a full rotation to get to that next coterminal angle. All we have to do is add 360 or subtract 360, since 360 is a full rotation. So negative 100 plus 360, that gets us 260. So that's, since it's positive, that's our positive coterminal angle. Okay. Now if we need it to be negative, if we subtract, that's going to make it negative again. So we'll negative 100 minus 360, negative 460 degrees. Now it is important to make sure you have the degrees. That tells us that it is an angle. Make sure you have that. Okay, so B, we start with 575. Again, just doing full rotations. Now, it's not a matter of just adding for one, subtracting for the next. Because if I subtract 360 from 575, I get 215. Okay, that's still positive, so I could use that as my positive coterminal angle. Now, you're not restricted to one rotation. So to get to that negative coterminal angle, we got to do two full rotations. So you're actually subtracting another 360 from that 215. That will get us to that negative 145 degrees. Okay, so you're not restricted on one single answer on these. You could subtract 360 a bunch of times if you wanted to and get a negative large number. Okay, as long as it's correct, you should be good. Okay, just add or subtract 360, get a positive and a negative coterminal angle. All right, now radian. Radian is another way to measure angles. Okay, it's the measure of an angle in standard position whose terminal side intercepts an arc of length r equal to the length of the radius. Now, I'm not too worried about you understanding it, but a radian, okay, in a full circle, there's 2 pi radians. Okay, now, so since there's 2 pi in terms of radians and a full rotation in degrees is 360, we have a conversion factor here. Okay, now, so 360 degrees, that's equal to 2 pi radians. Okay, now 180 degrees, which is half of 360, meaning there'd be pi radians. Okay, so the big thing to remember here a full rotation or 360 degrees is 2 pi, meaning a straight line is pi or 180 degrees. Now, just like you would convert feet to miles, whatever, okay, you got to have that conversion factor. We have that conversion factor right here, okay, to rewrite degrees and degree measures into radians multiplied by our conversion factor of pi over 180, because there's 1 pi and 180 degrees, or if you go on vice versa, 180 degrees in pi. Now, easy way to remember which one of those conversion factors to use. If you start with 320 degrees, okay, and we're multiplying, I can write 320 degrees over 1. And we're always multiplying by that conversion factor. In this case, we need to get rid of the degrees. So a degree over degree should cancel out. So the 180 should go on bottom in this case. Okay, so and then just multiplying across. Okay, degrees cancel. So we got 320 pi over 180. Okay, and then simplifying, I can cross out those zeros. We got 32 pi over 18. And then that can reduce further. Divide both top and bottom by 2. 16 pi over 9. Okay, now, always reduce. You need to reduce. Otherwise, you're going to lose points. If you were to leave that at 320 pi over 18, you're going to lose a point. Okay, or if you left it at 32 pi over 18, you would lose some points. You have to fully simplify. Okay, now going the opposite way. We got negative 5 pi over 12. Okay, and we need to multiply by our conversion factor. Now, since we're going from radians to degrees, I want to get rid of that pi. Pi over pi is going to cancel out. So we're going to use 180 over pi. So multiply across, we get negative 900 over 12, which will simplify, if you type it into your calculator, to negative 75 degrees. Again, if you're in terms of degrees, you need to have that degree symbol. Other than that, that is all for 13.2. Have a good day.